Hi everyone, I'm Zoe. In this lesson I'm going to focus on relationship between sides and angles of a right triangle. As you know, this kind of relationship is defined in trigonometry topic. Okay, now we know that if we have a right triangle, and this is the largest and biggest angle, 90 degree, and the sum of these two angles are 90 degree. But if we call this angle less than 90 degree theta, the opposite side of theta, we call it opposite side. And then next to theta, this angle, we call this adjacent to theta. And hypotenuse is the longest side of any right triangle. Okay, there is a relationship between these sides. For example, if we talk about relationship of opposite side of this angle over hypotenuse, we call this one is sine of theta. What is the sine of theta? The ratio of opposite side over hypotenuse side, right? But how about cosine of theta? Cosine of theta is relationship or ratio of adjacent side over hypotenuse. Okay, and tangent of theta is just opposite side over adjacent. And we have something else, cotangent. Cotangent is reciprocal of this one. Okay, this is opposite over adjacent. Cotangent is adjacent over opposite. Okay, and I showed you before, this is unit circle. Unit circle, we have a circle. The axis, x-axis is cosine of theta, and sine axis is, y-axis is sine of theta. Okay, we have from 0 degree to 300 degree, 360 degree, and we can say from 0 to 2 pi radian. Okay, before I start, I need to say something about calculator. If you want to calculate sine, cosine, tangent, and other relationship, you need to fix your mode of your calculator. For example, mine is Texas 83 from my student time. Okay, you can just go to mode. When you go to mode, it shows that some functions. One of the function is radian degree. You can choose this is radian or degree. If you mark this as a radian, any calculation is based of radian. Okay. If you choose degree, this is between 0 and 360. Just don't forget to use this one and fix this one before you calculate with calculator. Okay, now, as I told you before, you don't need to memorize everything, sine, cosine, tangent, cotangent of all just angles. But this one is sine of 0, sine of 30 degree, 45, 60, and 90 is necessary to know. You should memorize this one, but the rest of this is you are able to calculate the rest of this one. I show you how. For example, sine of 0 degree is 0. I can show you here because this is the sine the axis. Okay, 0 degrees here. Sine axis is 0 here. Okay, 30 degree is here. 30 degree is pi over 6. 30 degree. If you have 30 degree, for example, if you calculate this one, you see that this is this is sine. Sine, this, the ratio of this side over hypotenuse is half. Okay, half. Memorize this one. And 45 is exactly here. Pi over 2 divided by 2 is pi over 4. Okay? This radius is 1. You know, this is radius is 1. Okay. 5 pi over 4 is exactly in the middle. Sine and cosine are just equal. Sine and cosine are equal. And when you put this one, this is 1, and a squared plus b squared, or a squared plus a squared is 1, and you find the rad 2 over 2. Okay, just memorize this one too. About 60 degrees. 60 degrees, when you put this one 60 degrees here, pi over 3. Okay, memorize this one. It gets rad 3 over 2. And 90 degree, you see that the sine of 90 degree is 1. Because from 0 to here is 1, because radius is 1. But this is from here to here plus 1, from here to here is negative 1, and as well here. Okay, so how about the 180? 180 is easy because 0 is 0 degree is sine is 0, and for pi, sine of pi is 0 too. Okay. How about this one, 270 degree? 270 degree is equal to 3 pi over 2, because pi over 2, pi over 2, 2 pi over 2, 3 pi over 2. Okay, here you see that the sine of 270 is negative 1, right? But here is important, from 0 to 1 is important to memorize. The rest is very easy. Okay. What is the cosine of theta? Cosine of theta, cosine of 0 is equal to 90. What is a 90? Is sine of 90 degree is equal to cosine of 0 degree. You see here, the 0 degree is here. Cosine of 0 degree is plus 1. Okay, plus 1. Right? Okay, this one. Cosine of 30 degree is 60 degree for sine. Right? Okay. Rad 2 over 2, 40 degrees, sine of 45 degree is cosine of 41 because they are equal. It goes here. 1, 1, 0, 0, 3, radical 3 over 2, 1 over 2. Okay, cosine of 60 is equal to sine of 30, half. And cosine of 90 degree, as you see, cosine of 90 degree is 0. And as well, cosine of pi is negative 1. And cosine of 3 pi over 2 is 0. You see that? 0. Here is important. They are reciprocal, not reciprocal, but it's opposite to each other. Sine of 0 is cosine of 90. Sine of 30 is cosine of 60. These two are equal, and so on. Okay, how about tangent? Tangent is very easy because we know that tangent of theta is sine of theta over cosine of theta. Okay, we can find everything. Tangent of 0, 0 degree. How much is going to be? Sine of 0 degree over cosine of 0 degree. This is 0. Yeah? 0 over 1 is 0. You don't need to memorize this one, just this part, okay? If you go to, for example, SAT test, they have restriction over just using calculator. That's why. You need to memorize this one and find the rest of this. Okay, tangent of 0 is 0. How about tangent of 30 degree? Tangent of 30 degree is sine of 30 over cosine of 30. How much is going to be? Sine of 30 over cosine of 30. 1/2 over rad 3 over 2. You can simplify this. 1 times 2. 2 times rad 3. Yes? It gets 1 over rad 3. But 1 over rad 3 we need to rationalize. You know that. Because we don't keep this radical on the denominator. What can we do? Rad 3, everything is 1. Just this simplify gets 3. This one, rad 3 over 3. Okay, rad 3 over 3. Right? How about this one? Tangent of 45, of course, is sine over cosine r equals, so 1. Right? Tangent of 60 degree. Sine over cosine is rad 3 over 2 divide by 1 over 2. How much is going to be rad 3? Right? Okay. Sine of sine over cosine for tangent is 90 degree. 1 over 0. 1 over 0 is, we know that this is undefined. Huh? Because 1 over 0 is denominator is makes this one undefined. Okay, tangent of 180. Sine over cosine. 0 over -1 is 0. Tangent of 270 degree. -1 over 0. This is undefined again. Okay, how about cotangent? We know that the cotangent is here. I didn't write here. Cotangent of theta is opposite of this one or reciprocal of this one. Adjacent side over opposite side. Anything you have tangent, reciprocal of this one is cotangent. Or you can say cosine over sine. Okay? Okay. Cosine over sine of 0 degree, you know, as 1 over 0 undefined. Right? Cotangent of 30 degree. You can say cosine over sine, or you can reciprocal this one. This is reciprocal of this one gets 3 over rad 3. 3 over rad 3. Simplify, rationalize, and you have this one is 3, this is rad 3. Okay? Rad 3. Just simplify this one. What can I say? Okay. Cotangent of 30 degree. You can use this one too. Rad 3 over 2 divide by 1 over 2. It's rad 3. Yeah, this is rad 3. Easier. Okay. Cotangent of 45 degree. Cotangent, you can say the reciprocal of 1, or you can say the cosine over sine. Cosine over sine is 1. Reciprocal as 1 is 1. Cotangent of 60 degree. You can say cosine over sine is 1/2 over rad over 2 is rad over 3 over 2. Rad over 1 over 2 divided by this one gets 1 over rad 3. Okay? Or you could say the reciprocal of this one. 1 over rad 3. But rad 3, rationalizing, this is 3. Rad 3 over 3. Okay. How about cotangent of 90 degree? Cosine over sine is 0. Cotangent of 180 degree is cosine over sine. Okay, this is -1 over 0 undefined. Cotangent of 270 degrees, this is 3 pi over 2. Cosine over sine is 0, right? Just, you see that. You don't need to memorize everything. Just memorize this one. Sine of 0, sine of 30 degrees, sine of 45 degrees, 60 degrees, and sine of 90 degrees. That's it. The rest of this one is possible, because you know that the cosine is, the cosine of this one is, cosine of 0 is 90. This one is this one. Exactly, you go just here, okay? This one. And for tangent, you can divide this sine over cosine, sine over cosine, sine over cosine. And for cotangent, you can say reciprocal of this one. Or you can say cosine over sine. Before you take a test, if it open book is okay. For like GED or something, I don't know, in GED, you need to use this one or not. But SAT is more restricted. Okay, you can use your calculator or maybe not open book. But for if there is not open book, you must be ready. Just memorize this part and the rest of this you can calculate. Good? Okay, and this one, I recommend you, strongly recommend you to use this unit circle. If you have a unit circle, you can see that cosine of 0 is 1, cosine of pi is -1. You see that. This is coordinate system. Sine of 90 is +1, sine of this one is this, sine of 0 degree is 0. You can see many things on this one. This is unit circle. A circle with 1 as a radius. Okay, and this is the ratio of the sides of a right triangle. And the trigonometry is about this one, the relationship between sides and angles. The Pythagorean theorem was about the relationship of just these sides. This side is square equals to the sum of square of this one and this one. Just sides. But trigonometry is everything. Okay? Okay, hope you like this this lesson and use this one when you go to your test, when you go and take any test, or when you do your homework. But don't forget to just adjust this one. Go to mode and just go to down to radian or degree. If you want to do this one 30 degree, for example, say sine of 30, use this one. If you want to use pi over 6, pi over 4, something and radian, use radian. You know, when you go to higher math, you usually use this one, radian. Or when you go to, for example, study electronic, when you use this one as a sine and cosine of many sine of cosine you use when you study electronic. This is mostly about this one. For example, when you go to study waves in physics, you use this one, pi and this. For example, if you want to show waves, a wavelength you show on radian. For example, say sine is this one. Sine goes up to 1, -1, goes up and comes down here, down and here. Everything we can say on between 0 and, for example, this is pi over 2. Pi over 2 is 1. This is sine theta, for example. This is pi over 2 gets 1. Here gets 0. Here is pi over 2. The domain is everything is according to radian. You can use this degree too, but in higher mathematics you use mostly this radian. Okay, thank you for watching me, and good luck, and see you later. Thanks.